This video is about type 1 and type 2 errors. In a hypothesis test, HO, there is no disease. H1, there is a disease. If the test result is positive, we will reject HO. When test result is negative, fail to reject HO. But if the actual condition, no disease, but the test result is positive, we call it false positive or type 1 error. If actual condition is disease present, but the test result is negative, we call this false negative or type 2 error. Type 1 error, false positive. Definition: rejecting the null hypothesis. One is actually true. Explanation: you conclude there is an effect or difference when none exists. Example: a medical test says a patient has a disease when they actually don't. Type 1 error is controlled by the significance level alpha. Type 2 error, false negative. Definition: failing to reject the null hypothesis when it's actually false. Explanation: you conclude there is no effect or difference when actually exists. Example: a medical test says a patient is healthy when they actually have the disease. Related to power of the test, 1 minus beta, which increases with larger sample size and better measurement tools. Let's talk about significance level alpha. Is the probability of rejecting HO when HO is actually true. This is also called the type 1 error rate. Symbolically, alpha equals P of reject HO given that HO is true. If alpha equals 0.05, you are allowing a 5% chance of falsely concluding there is an effect, when in reality there isn't. Power of the test is the probability of correctly rejecting HO when HO is false. In other words, it's how good your test is at detecting a real effect. Symbolically, power equals P of rejecting HO given that HO is false. Related to type 2 error beta, type 2 error beta equals probability of failing to reject HO given that HO is false. Let's compare type 1 error to type 2 error. For type 1 error, rejecting a true HO. Type 2 error, failing to reject a false HO. Symbol: use significance level alpha for type 1 error. The probability of error beta is for type 2 error. Impact from type 1 error can lead to unnecessary action or false alarm. Type 2 error can lead to missed opportunities or overlooked risks. How to control type 1 error? Try to set a lower alpha. How to control type 2 error? Increase sample size or power. Concept check 1. Match each term to its correct definition. Type 1 error. Rejecting a true null hypothesis. Type 2 error. Failing to reject a false null hypothesis. Null hypothesis. The assumption that there is no effect or difference. It's always dealing with equal sign. Alternative hypothesis. The assumption that there is an effect or difference. Concept check 2. Read each scenario and identify the type of error. A new drug is tested and appears effective, but in reality it has no effect. Just check whether HO is true or not true. If HO is true, then it goes type 1 error. If HO is not true, it goes type 2 error. In reality, it has no effect means HO is true. So type 1 error. Question 2. A school concludes that a new teaching method doesn't improve scores, but it actually does. HO is not true means H1 is true. It actually does means H1 is true and HO is not true. So this is error type 2. 3. A researcher claims a difference in test scores between two groups, but the difference is due to chance, which means HO is true. So error type is 1. 4. A scientist fails to detect a real effect in an experiment. Real effect means H1 is true, so HO is not true. Error type 2. How to calculate the probability of type 1 error? We know type 1 error is rejecting HO when it's true. The probability of type 1 error equals probability of critical region. In normal distribution, this significance level alpha is the probability of type 1 error. For binomial distribution, you need to figure out critical value. For Poisson distribution, it's the same as binomial distribution. We need to figure out the critical value. Then based on what kind of test to figure out probability of type 1 error. How to calculate the probability of type 2 error? Based on the given information mu1, p1, and m1. The probability of type 2 error equals probability of non-critical region.